Big data.
Big data.
The big data.
Big data. The big data.
Today's big data.
Last year in 2012, I went to a seminar, no, it's actually a speech, by the new CEO of VMware. And he was talking about 4 big trends in Silicon Valley. Question for you guys, what are the 4 big trends? Mobility, okay, mobile, big data, cloud, social, exactly. Okay, so he actually gave a word, one buzzword, that's homophobic. So that actually explains 4 of these. So our next speaker is actually going to talk about 2 of them. And he's also from VMware. Charles Fan. Charles is the Senior Vice President. Charles is the Senior Vice President of R&D at VMware, leading the global R&D team of VMware's application storage and data products. Charles and his team are responsible for the software-defined storage and big data strategy and execution at VMware, a leader in cloud infrastructure. Prior to this role, Charles was the founder and leader of both the VMware China R&D Center and the EMC China Center of Excellence. Prior to his China roles, Charles was a co-founder and CTO of Rainfinity, which was acquired by EMC in 2005. Charles is an expert in distributed systems and network storage technologies. He received his PhD and Master of Science in Electrical Engineering from the California Institute of Technology and his Bachelor of Engineering from the Cooper Union. Today, he is going to talk about 5 major industry trends that are contributors to make cloud computing and big data real. He is going to tell us that these are not just the buzzwords, but reality in our life. So now let's welcome Charles Fan.
Thank you for the introduction, and I really enjoyed Dennis' talk. And while he is very uniquely qualified to give the speech, I'm very unqualified. I'm not a semiconductor professional, and I was not born in 1947. But my only connection, through social is my mother is actually a semiconductor professional. And I also know many of her students who are also semiconductor professionals. So that connects me to that. And she was born even before 1947. So I think the last talk we talked about the small chips, and I'm going to go into the big data a bit. And big data is a buzzword, and it's a big buzzword. I remember Peng Liang was just telling me I was the only speaker, even though I'm not a semiconductor professional, that have 2 appearances at the Symposium in the last 3 years. And I remember the last time we talked about cloud, because that was like the big buzzword of the time. And now big data is even hotter. And but the 2 things are actually quite related. And I've made a good living trying to stay on top of those buzzwords. And this is I think the same slides I gave about 3 years ago about cloud is showing what a transformational time we are at. And this is the starting point, reflect to the last talk, is also from the 1950s when the mainframe started coming to this world, and we went through a few generations of computing technology. And now we kind of in the cloud era, where the cloud data center is a new server, and many of the mobile devices are the new clients. And while this is happening, a lot of things, it has a fundamental impact on how things are interconnected, how data are generated, and how they are consumed. In particular, whenever anything increased by order of magnitude, there's a new set of challenges, a new set of problems to be solved, and a new set of opportunities to be grasped. In particular, in the new cloud era, as well as in the what we call Internet of Things, the connected devices by the network are increasing by order of magnitude. It's no longer the people who are behind those connected devices, various kind of computers, but it's also various kind of sensors, various kind of cameras, various kind of other information generation devices without a one body behind them. And this increases the number of sources, the diversity of sources, and the volume of the data that are being generated. And while there are a lot of data being generated, you cannot just throw them away because there are a lot of insights actually can be gained from those data. And those insights can in turn help generating revenue for the business and help the businesses become more competitive. This is really, fundamentally helping IT, information technology, to be relevant to the success of businesses. And I think that's one fundamental reason why big data is so important and how it's connected to the internet and to the cloud computing world. At the same time, big data is a very a big concept. It's like a big elephant. So if you ask different people working in different fields, they may be touching the different parts of big data. One way of looking at big data is there are 4 layers. Each of them have its unique set of problems and unique set of opportunities. The uppermost layer is the big data applications. This is actually what you do with the data that actually generate the insights to help the business. The layer below it are the big data analytics. These are the tools and algorithms, the mathematics that's needed to actually perform the analysis of the data. And the layer below it is data management layer. This is what we classically call databases. But there are actually new sets of technologies, how you add structure or add indices to the data to allow the data analytics to happen in a more efficient fashion. And then the lowest layer is the big data infrastructure. It is the hardware and the software that are kind of the underlying platform that stores the data and that computes the data. So those are the one way of you can looking at various layers where different interesting innovations can happen to manage this increasing amount of volume, velocity, and variety of data and extracting the value from them. And the area I working in is more related to the second layer from the bottom, which is the data management layer. So I will not go into the other 3 layers, but just give you some of my observations on the data management. What are potential changes or disruptions that are going to stir things up in the database world that actually going to make things pretty interesting for big companies as well as for startups. So going into that, let's look at databases first. I think even though we work in semiconductor industry, database is such a common computer science concept. I think probably most of us have a basic understanding of it. It was invented about 40 years ago, the relational databases. This is the predominant styles of how data is managed today. They are being put into tables, and there are rows and columns, and you can essentially, with that math, with relational algebra, you can process data in a very efficient fashion. And what this is particularly good for is for transactional applications. Many of the leading computer applications that are running the mission-critical tasks for business today are transactional applications. They ensure each transaction is committed once and only once. And when you go online buy a plane ticket, it doesn't give you 2 seats and that doesn't give you 0 seat, and nobody else can take your seat. And behind it, what guarantees that consistency is actually the databases. Because there are many application servers, many web servers, but everything has to commit to that database, and that database ensure this consistency. And what we commonly call the asset. It needs to make sure a transaction is atomic, is consistent, is well isolated from each other, and it's durable, that it's put on a disk. So that's the assets transactions that the relational database are very good for. And it's also very good for very efficient queries. So once you put this database schema onto your data, you can query it in a very, very fast fashion, much faster than you just do a scan and do a search of the data. And from the transactional databases, then you also have operational databases and data warehouses that are performing other tasks. And there's the ecosystem being built and many tools that are created to interconnect all those databases. They are typically called ETL tools, where you extract, translate, and load data from one database to the other. And on top of this data fabric, you build hundreds or thousands of applications, those including the financial applications, the ERP applications, the HR applications, various other applications that make business run around. It replaces paper, it replaces paper bills, it replaces your accounting books, and all of that is digitized and put in the system. And as this IT world is being built, database is becoming a pretty central and sticky part of the IT stack. You know, people can change their servers. People can sometimes even change their storage, even though that takes a little harder. But almost never people change their databases, because it's very difficult to change your database, because you need to rewrite all the hundreds or thousands of applications on top of it. And when you need to create a new application, you just point that to the same database. And this platform effect really makes companies like Oracle a very strong force in the enterprise IT world, because people, even though people don't particularly like Larry Ellison, and they don't particularly like the company, but they just cannot leave Oracle, because that's what's running their business. So this is the database world that certainly Larry Ellison likes a lot, and is making a lot of money on it. And it seems very secure, because very difficult can you have a new database to challenge the incumbent that's there. But I would argue there are 5 things that are happening, actually making the database world a little less secure, or a little less stable. The first thing is the big data itself. The nature of the data is changing. There are the new machine-generated data, the data that are generated by the servers, that generated by the sensors, generated by the RFIDs, by various sources that are happening. The nature of these data are slightly different from the data that relational database were designed for. Now, for the transactional type of data, they are digitizing what used to be records. When you have accounting books, you have rows or you have records. When you have a library, that you have those index cards, those are records, and database turns them into digital forms. And for those type of data, you kind of need to go through the whole life cycle. For those data, you need to create it, you need to read it, you need to update it, and you need to delete it. You kind of go through the full information life cycle, and each of those you need to make sure it's consistent. With new type of data, the interesting part is you don't update it so much. So even though the data is generated in a fast pace, in high volume, but very rarely do you modify your video. Very rarely do you actually change even your tweets or your Facebook postings. You don't go back and change your log. Those data are kind of generated once. They will be processed many times, but they don't get updated a lot. And also, they don't get deleted a lot. You need to keep them for a long time. They just keep piling on and on. What happens, they do get replicated quite a bit, and they do get appended, so there are more things being added to it all the time. And you do need to process them very frequently. You do need to process them at the real time when they are being created, and you sometimes need to process them in a batch fashion to be able to gain the insights to predict the future. So instead of CRUD type of data, the new type of data, how I define big data, it's a crap. It's a create, replicate, append, and process. That's a new life cycle of this type of stream-based big data. And the big insights, aside from the acronym here, is that for this type of data, it's not a design center for classic relational databases. And often, the relational databases are not scalable enough, not well suited enough to process this type of data, to be able to either handle the volume of them or to be able to process them fast enough to gain the real-time insights. But at the same time, a lot of the good mathematics and a lot of the good algorithm inside relational database may become less relevant in this world. So that calls for a new class of technologies that we probably have heard of a technology called Hadoop. That's kind of the earlier incarnation of the new big data processing technologies. And there are new kind of processing engines and query engines that are being built on top of Hadoop and in this Hadoop ecosystem. And there are also people working on alternatives to Hadoop, which in itself is really just open source implementation of what Google implemented, the MapReduce system inside of the Google internet data centers. So there are a lot of active innovations that are happening in this field to design a real data management system for this type of crap data rather than the CRUD type of data. So that's the first observation here. The second observation is back to the cloud itself. As I mentioned, in the database world, all the databases are all within your data center, and they're all interconnected by the various ETL tools. So when you create a new application, there's a standard way to access those data. There's a standard SQL, SQL query method, and there's a standard ODBC, JDBC kind of driver that connects your application to those databases. But cloud has an interesting effect. Whether the enterprise IT allows it or not, there are increasing number of SaaS applications that are being used by the enterprises. Things like the CRM, Salesforce, HR, the Workday, and the last time when VMware did a count, we have over 20 different SaaS applications in the works. And besides software as a service, there are also infrastructure as a service, as well as platform as a service that are starting to gaining a footprint inside of the enterprise IT as well. So with all those cloud applications in existence, data no longer all sit behind the firewalls inside of Oracle. They are usually co-located to where the application is. And Salesforce data is at Salesforce data center, and Workday data is at Workday data center. At the same time, these enterprises still have their own private data center, and they still have their databases there. Now, if I need to write a new application to access the data across all these data sources, there's no longer a standard way. So it really loosens this platform effect the current database vendor have hold on their customers. At the same time, it opens an area for innovation to create a kind of a new data integration layer to interconnect the data sources across a multi-cloud world, including your private data center. So if I want to do a application that can query my customer data in Salesforce and try to correlate them with the financial data as well as other social data that are connected in Facebook somewhere, I need a new data fabric that can allow me to get to all those data sources and be able to join them and process them. So it's also in a very interesting area for a new cloud data fabric that can interconnect those data sources and that can allow the analytics to happen on top of it. The third observation is the consumerization of IT. A common experience I believe all of us are seeing is from our company we have the application and services provided by our IT groups. And what we have found is the experience we get as consumers from the various internet services is actually superior to the experiences we get from our corporate IT. And this kind of drives the need for this consumerization IT. It's really, if you look at the last 60 years in the life of information technology, if you see it as a race between the corporate IT and consumer experiences, in the first 30 years, definitely corporate is way ahead. As an individual, for me to get access to a computer is not so easy. And I need to work for a really rich company to get access to the big computers. But PC is really an equalizer that's really, create an equal opportunity racetrack. And now with the internet, I think the corporate IT is actually falling behind You're actually getting much better information technology experiences as a consumer than actually as a knowledge worker in an enterprise. And I don't think the enterprise IT should give up. It's really some catch up for them to do, and they still have the ownership of the enterprise data, of the enterprise information. The key is how to make the data, how to liberate those data, how to get those data available to every knowledge workers so that they can visualize, they can access, they can analyze those data in a very easy way. From a CEO to the technologist to the truck drivers, they can all be the happy consumers of these data and enjoy the benefit from those data. And there are a lot of activities that are happening in those areas, and that is actually shaking up the whole data warehouse, data mining, data analytics world as well. So that's the kind of three, I think, potential disruptive trends that are opening new opportunities. Now, in addition to these three things, there are also two things that allow the two worlds to coexist. So why the two worlds need to coexist is, make no mistakes, while this side is emerging, the other side, the database, is not going away. It's going to continue to power the transactional workload to keep the business running. So the task is not reduced from the IT people. They need to keep the left-hand side going while have some money to start going to the brave new world of data cloud. And to make the two worlds to coexist and to work, I think two things are very important. The first is the virtualization, abstraction, and operationalization and automation of these IT infrastructure. Because from the left-hand side to both of these worlds, you are going from a more unified model to a more heterogeneous world. And it adds cost to the IT infrastructure operations. And once you have a very virtualized, automated infrastructure that reduces the cost on the left-hand side to allows the customer to free up the money to invest in the right-hand side, it also helps the operationalization of the right-hand side, a heterogeneous world, much easier. Because we are in a period where there is no clear winner on the right-hand side yet. The customer often needs to set up many different competing technologies, many different kind of very different technologies. And the automation of the infrastructure of it actually really helps customer to try them out much more easily. The second bridging force is open source. It's been around for a while now, just similar to virtualization, but it is gaining a stronger influence in the enterprise IT. It's no longer only for the avant-garde developers. It is something even the most traditional infrastructure operators are looking into. And it has at least two fundamental effects in the data management world. One is commoditization. For the databases, it's a great technology, but it is a mature technology that has been around for 40 years. And with any mature technology, it's subject to commoditization, meaning the gap between the state of the art and the open source is narrower and narrower. So that means for many of the new applications, for many of the new workloads, it's much easier for customers to make a decision to use a MySQL or Postgres or one of the other open source databases instead of the more expensive database choices. The second effect is maybe even more fundamental, is because it really lowers the barrier for adoption for the newer technologies. Most of the new database technologies, data management technologies, the NoSQL, the big data technologies, come to this world in the form of open source. So it basically doesn't require an enterprise IT or a developer to make a big investment to try it out. They can really start using it, and it makes the developer and the customer to be the kingmaker. What will be the new winner of the data management technologies? So open source is a fundamental force that's underlying this transformation as well. So the combination of these 5 things, we believe, will open a new era in data management, and that in turn have implications to the data infrastructure as well as the data analytics and data applications that's sitting on top of it. And it is a fundamental force in the big data world. So I'm going to just go over one more slide. This is a picture of a potential CRAFT-DB. What is this new database that manages this stream-based real-time data? On the top left-hand side, you have various information generation devices. They are coming from various sources and they're coming into our system. On the top right-hand side, you have various consumers of the insights that are generated by this data, and that can enable them into actions. And then inside of the system, you have many components. You need to have a fundamental information storage infrastructure that is scalable, that is distributed, that can go across multiple geographies, that can hold these data. And then you need to have a way to process them in various time frames. You need to often process the real-time incoming data in a real-time fashion, and for that to spring into action. And sometimes you need to really process nightly, maybe the accumulated data, to be able to give a dashboard and guidance to your executives going into the future. And you often don't know all the questions you need to ask, so you need to kind of interactive query engine to be able to process these data in a more efficient fashion, because the bottom data, big data infrastructure is very scalable, very big, and it takes a long time for you to go through them. So you need various kind of in-memory technologies to extract those data and organize it in an efficient way to allow the question to be asked and answer to come back in a relatively fast way. So this is kind of one prototypical big data systems, and there are innovations that are happening in each of these boxes. So that basically concludes kind of a basic introduction in the second layer of this big data. And I believe that the area, I think I'll just stop in the last, the next ones are more commercials for VMware. So I'll skip all that. So I think this area is very interesting, and it's only beginning. And companies like VMware are looking at it with a big, wide open eye. And VMware is a company doing infrastructure software, but at the same time, we believe the opportunity in this world is so big that even as an infrastructure company, we want to go into it. And I think it also has implications to the semiconductor industry. How do you process data in a very parallel and a fast fashion? And how do you embed a lot of the potential predicates even that are common in the data processing into the semiconductors, potentially, both into the general purpose processors and maybe in the more specialized hardware. So I think there are innovations both in the computing and the storage and even networking side of semiconductors. So I think this symposium is very timely, and I'm also happy to answer any questions, although my time is up. So I'll be answering questions maybe in the breaks, or you can certainly find me through the CASPA organization. Okay, I have 5 minutes. Good.